Okay, I think I was muted there. Sorry. Okay, so we're still on this serverless part of the module, and we're nearly finished it at this stage now. But I've got this lecture and one more lecture, I'd say, to cover before I can complete everything that I want to complete before I can give you the assignment. Although I'll probably put the assignment spec up on the site maybe before the end of this week, so you can have a look at it. So we're working our way through these slides here. And these slides are looking at a service called API Gateway, which is the service for creating web APIs, which is something that you're very familiar with from the Web App Dev module in the previous semester. So I've kind of talked a little bit through these slides. Let's just try and go back to here maybe. So this is the kind of scenario that we want to be able to create, where we've got some lambdas, plural. We've got a bunch of lambdas that are implementing functionality, probably talking to a database, although that's not significant. And we want, though, the collection of lambdas, which kind of represent an overall web API's behavior. We want to put an interface in front of them, and that interface then is what clients will connect with. And in the case of AWS, anyway, this interface here is implemented using the API Gateway service. Yeah. But more generally, this API gateway can be the interface for any type of backend. It doesn't have to be lambdas. And so where we kind of left it off the last day was, so we were talking about the integration of your web API, which is here, integrating it with your backend. And there are four types of integrations. Um, There's kind of a mock integration, which really means you don't have any backend yet. Sometimes the interface, the web API, can be developed before the backend can be developed. And if that's the case, then you use this mock integration as a kind of a dummy backend. The second type of integration is where the backend is some other service other than Lambda. And I talked about the problems associated with that the last day. So we'll move on from there. A third type of integration, which is the one that we're interested in, it's called AWS Proxy or Lambda Proxy, where the backend is implemented with Lambdas. And we talked about that the last day. The fourth type of integration, just for completeness, is called HTTP proxy. And it's specifically for the case where your backend is actually a load balancer. So that's a scenario that can arise sometimes in industry. Because as you know, a load balancer, it understands HTTP. So your API gateway in that case is transitioning from HTTP to HTTP. So in a way, it doesn't have any transformation work to do. It's simply just proxying any HTTP requests that it receives. It's simply just proxying them on to your load balancer. Yeah. Uh, but we're not interested in that integration either because we won't be looking at load balancers. So the focus is this Lambda proxy or AWS proxy, as it's called. Uh, CORS, as something that we're very familiar with, CORS is something that you need to configure for your web API. Um, I don't need to go into explaining what CORS is all about, but suffice it to say that as we'll see, we need to configure the CORS integration for any web API that we create using API Gateway. Right. So a quick demo, and the demo is kind of your 101 demo. Let's suppose we're implementing a web API for managing to-dos. Pretty boring stuff, but anyway. And let's supposing that this is the kind of specification, let's say, for our web API. So we've got two endpoints, to use the language of web APIs. We've got a slash to-dos endpoint and a slash to-dos slash to-do ID endpoint. The to-dos endpoint needs to support both get and post requests. And the idea is that if it's a get request to this endpoint, then we'd like the backend to return all of the to-dos in our database, let's say. Yeah. Whereas if it's a post request to this endpoint, the post, as you know, will indicate that we are trying to add a new to-do to our database. So the post is going to include a payload. For this endpoint, the to-do ID here is what we would call a path parameter within our overall endpoint path, and that only supports the get method request. And again, as you would be very familiar with now, a get request to this kind of endpoint, the idea is that the client is looking for this particular to do. And let's just, for the sake of it as well, let's say this path, this endpoint also supports query string parameters. And in particular, it supports a query string parameter called completed. I guess the idea there is we're trying to ask the backend only return this to do to me if the to do is checked as completed. Also, it contains maybe query string parameter as well. We needn't worry too much about what these query string parameters represent in this case. All we're really interested in is how do we access query string parameters in our backend if they're part of a particular HTTP request. Okay, so to look at the implementation of that sample or that little specification. So here I've got my CDK. So we're back into the CDK world now. Here I've got my CDK project, and here's my stack file. Now, we're not really interested now in the Lambda's functionality at this stage because, it's very slight kind of stuff we would have done in the previous lab where we've got a Lambda that's reading from a database and writing to a database. So the detail of that isn't really where our focus needs to be right now. So what I've just done is I have sorry, let's go up to this top of the stack. I've got a Lambda function here, and the actual implementation of the Lambda, it doesn't really do anything. It just has a console log statement and a return statement with a return of 2000. So the Lambda is not really of any interest to us. And I'm using the same Lambda. I'm going to use the same Lambda as the backend for all of my endpoints, which again wouldn't be the case. Okay, so that's the Lambda. So here's where we start our API gateway stuff. So yet again, in terms of constructs, there's an L2 construct called REST API, which is part of the CDK library. And like all other L2 construct, it has three parameters. The first parameter is the scope. So the scope is always this, as we know. The second parameter is just a string ID identifier for this construct. That's pretty arbitrary as well. And the rest then is the actual configuration for this particular construct. And because it's a REST API, construct, then kind of things that we can set are um, what particular stage is this API associated with? By stage, we mean kind of environment. Is it for dev, for prod, for test, for QA, for staging? Okay, so I'm going to say this is a dev stage web API. And as you know, when I mentioned the last day, API Gateway allows you to have multiple stages uh, deployed in parallel. So for a particular web API, we might have a dev stage implementation of it, a prod stage implementation, a test stage implementation, etc., etc. So this is the dev stage implementation, Maria. And this stuff here then is actually the CORS configuration. Now I've just again decided arbitrarily that the CORS configuration it allows access to any origin, set it to star, and all of the methods are supported, as we can see here. And the other two parts we needn't really be interested or concern ourselves with. So that creates, if you like, a blank canvas of a REST API. The rest then is adding on our different endpoints. And so although uh, API Gateway doesn't call them endpoints, it calls them resources. So here we are adding a resource, aka adding an endpoint. In this case, we're adding an endpoint to the root of my web API. So it's straight after the slash. And here's the actual uh, path, if you like, uh, that I'm adding on. So that's the slash to-dos part. Okay, so that line of code has added an endpoint. Then we add a method to that endpoint. And so we're adding the post method. And here is where we actually specify the integration with the backend. So Lambda integration clearly tells us that we are integrating this integrating this endpoint with a Lambda backend as opposed to an SQSQ or an application load balancer. Yeah. And I'm referring to my Lambda function that I've defined at the top of the file. And this is just standard. Sorry, where is it? Oh yeah, this is just standard. We wanted to proxy on. We don't want it to do any kind of uh, any transformation of the HTTP request. Similarly, we need to, sorry, that was the get. Similarly, we need to add on the post method to the same endpoint. So you can add as many methods. Well, there are only four, I guess, really. Get, put, post, delete. And again, it's a Lambda integration. And as I said there, I'm actually integrating everything with the same Lambda just to have some sort of backend. So the effect now of all of this code here, the effect has been to fully set up uh, all of this. Now I need to set up this, but essentially what I'm doing here is I'm adding a new endpoint or a new path resource onto the existing resource. Yeah, so you can see here now, let's see, I'm adding a resource. I'm not adding it to the root this time, I'm adding it to the other resource that I've already created. And the path part of the resource, I'm enclosing in curly braces, and that means that this part of the path is a path variable. Okay. You could have a static part as well. Like you could have, for example, you know, whatever, slash ABC slash doesn't have to be just the variable part. What did I do there? Sorry, beg your pardon, that was a bit messy. Let me undo that. You can have, slash ABC, or you could have the slash after the variable. That's completely arbitrary. As long as you wrap, this in curly braces, then that's telling API Gateway that it's actually a path variable. And the path variable name is completely arbitrary, but whatever name you use here, that's what you're going to use to access that particular variable within your Lambda function. And again, we're adding on the methods uh, for this particular endpoint or resource. And so that's it. That now has created this endpoint. You don't have anything about the query string at this stage. Okay, so that's my stack, my Lambda, which would typically be Lambdas. There might be a database as well, etc., but we're just ignoring all that for now. And the rest then is my my web API. So I've done CDK deploy already of this stack. And even though I don't have any kind of terminal output, I don't have any terminal output here. When you have a REST API or an API gateway instance, if you like, in your stack, then automatically the CDK framework will output the URL, this kind of base URL of your web API. And that's what you're seeing here. Okay, so this is the base URL from my web API. Okay, and if we look at the management console and go into the API Gateway service, and select APIs. Now, here's the one, which one? This is the one that we're currently looking at. This is another one that I'll talk about later on if I get to it today. So this is the one that I've just deployed. And the to-do API that comes from the name that you give it here. And if you click into it, then you get a nice visual representation of the structure of your web API, so that all kind of matches up. And over here as well, if you select stages, then it's telling us we only have one stage deployed for this particular web API, which is the dev stage. Yeah. And if I just select that, here's the, where is it? Did I select it? I'm looking for the URL. It's probably staring at me now. Where is it? Oh yeah, there's the URL there. And that's the URL that would have been outputted on the terminal when I did the CDK deploy. So I've grabbed that URL. Now before I try and trigger anything, I'm going to switch over to CloudWatch. I just want to clean up my logs, which, as you know now, is something that I like to do, just to make sure we're always looking at the most current logs. Okay, so that's good. Now, if I switch over to Postman, and I have a Postman collection created for myself, which is here. And in the variables, I have a variable called URL, and this is the actual URL that I've pasted in already. So if we try and do a get, send a get request to slash to dos slash to do ID, and I go send. So this is the response that I'm getting back from the Lambda, and I showed you the Lambda there. Let's just go back and confirm that that is coming from my Lambda. And yeah, that's what where is the message? There's the message there, right? Just success. So it looks like my Lambda was triggered. And I can confirm that. We always like to look at the CloudWatch logs to examine the execution of the Lambda. So if I do a refresh of this, so there's my log group for the Lambda. And here's my log stream. Now, when I was talking about the integration, I said that we just go back to the slides. Uh, so this is the type of integration that we have now between our web API and our backend. And what I said was the HTTP request, all parts of it, and by all parts of it, I mean the HTTP headers, the payload, if there is a payload, the query string, if there is a query string, the path variables, if there are path variables, all of that information will be put into the event object that is passed to the Lambda function when it's triggered. And API Gateway kind of takes care of that. We know that our Lambda function has two uh, parameters. The first one is the event object. So if we look at the event object for our Lambda, then we can find all of the information that we need to know about the HTTP request. We can find that information inside in the event object of the Lambda function. For example, we'd like to find the path variable, which was 1234 in our case. Um, so can we do that? So if we look at and we know that our Lambda has a console log at the very beginning, and console logs the event object itself, as we always do. So that corresponds to this part of the log stream here. And so you can see there's a lot of stuff inside in the event object, and the vast majority of it is related to the actual HTTP request. Like these are all HTTP headers that were that were generated by Postman in my case. Uh, yeah. Okay. These are all of the headers that were generated by Postman. We're not really interested in those. What we are interested in is where are the path parameters or path variables, if there were any, and we know there was one. So if we scroll down to, let's see, I skipped over them. I don't see them there, but they should be. Oh, there we go. Sorry, no, that's false alarm. Here we go. So what API Gateway has done is it has created a property in my event object called pat parameters, and it has assigned an object to that. And the keys in the object will be the pat variable names. So the to-do ID there, and here's the value 1234, but the key there, to-do ID, that comes from sorry, not which file is it? This one. Whatever name you used here. So that's fine. Let's suppose we send a request with with a query string. So I can do that by, I'm just going to pull this down a little bit. So let's supposing we send, and it really doesn't matter what the query strings are. So here are my key value pairs. We don't really care about the values, but they are the values anyway. So if I send that request, and okay, it seems to have worked. I'm getting success down here. Let's look at the log stream now and see, can we find these query string key value pairs? So this is the log stream in this case. And we need to expand that. And there you can see this part of the event object contains the query string values that our Lambda function would be interested in extracting and using in whatever way it needs to use it. The final thing is if the request contains a payload or a body, which would be typical with a post request. So if we try and send a post request, so let's supposing this is the structure of a to-do, and it's a post request to the slash to-do endpoint. Send that. Now in our case, okay, it's finishing up with the same Lambda, but what we want to do now is look inside the event object for this particular triggering of the Lambda and see, can we find this information? Go back to CloudWatch logs. I'm just going to do a manual refresh. It may have reused the same micro VM now, so it will be the same log stream. Yeah, I think it's probably inside in this log stream. So this log stream has an init part, it has a start. So that start relates to the second request that I sent. The third request then was the post. So that looks like this part of the stream. And so if I now expand this, which is the console log of the event object for the post request, and right down at the bottom, there's a property called body. But you can see the value there. The value is actually a stringified form of the JSON object that was the body. So you always have to be careful that within our Lambda function, we would need to parse this string just using the JSON.parse method, which we play with in the labs anyway. So that's fine. So that's the proof that the integration done by API Gateway seems to be working fine for us. So we can access anything within our Lambda function that relates to the HTTP request by essentially poking around in the event object. Okay, so that's that demo. They're just screenshots from the management console. That's the stack code, which I've talked my way through. All I'm saying in this slide here is, if there are query string parameters in the HTTP request, how do you get at them within the Lambda function? Well, I've just demonstrated that to you. The screenshot is just showing an example of it. Similarly, if there are path parameters in the URL itself, how do you get at those within the Lambda function? Well, I've also demonstrated that to you, and this is just giving an example of it and a screenshot from the log stream. Now, we're familiar with API keys from the web app dev module. API keys are kind of a way of authenticating a client authenticating itself with a web API. And not surprisingly, API Gateway supports the use of API keys included with HTTP requests. So what you can do in the CDK stack code is you can get the CDK via CloudFormation to generate an API key or keys if you want to, but we'll just deal with the singular. You can get CloudFormation to generate an API key for a web API. And if we just go back to the management console and go into API Gateway, so if I did have some CDK code asking for an API key to be generated, then when I look at my API Gateway Management Console for the, well, you can see here there is a part called API Keys. And so we would have an entry here for a particular API key. And we know that an API key is just an alphanumeric string, okay? And we know what the role of the API or the purpose of the API keys are. So I'm just saying here that they're just alphanumeric strings, values, and that they're used to you essentially kind of give the API keys to whoever your customers are. And our customers typically, we tend to use them mainly for developers to allow developers to authenticate themselves against the web API. And so here I'm just saying you can generate an API key in API Gateway. Okay, it's just more CDK stack code. There's an actual L2 construct for it. You can actually, as well, I'm saying here, you can import API keys if that's be the case. And some organizations would do that. They would prefer to generate the API key elsewhere and then just import that key into API Gateway. Although we're only interested in where you actually get the CDK to do it for you. Now, also we have this concept of usage plans, And what a usage plan is, it kind of indicates what permissions an API key has in terms of what particular endpoints it has access to, what methods of what endpoints it has access to, and you can also associate or you can also configure rate limits in your usage plan. So you might want to limit the number of requests that you're allowing your user to uh, send to your web API over a particular period of time. So these usage plans, then you kind of link a usage plan with an API key. And so now the usage plan kind of defines the scope, if you like, of the API keys usage in terms of rate limits, as I said, and also in terms of which particular stages of the web API does it have access to, which endpoints, and which methods of which endpoints. And they go hand in hand. You have to have a usage plan for an API key. The API key on its own isn't sufficient. But again, a usage plan is something that you can also get the CDK stack to create for you. So there's another L2 construct associated with that, or for the to facilitate the creation of that. And how you hook all of these things up together. I'm trying to kind of describe that here in this image, right? So you have a web API. We know how to create them. You have a usage plan. Okay, we haven't created any usage plan in our CDK code, but it's just more CDK code, really. And you create the usage plan kind of independent of your web API. You also create an API key independent of everything else, but then you kind of have to hook them up to one another. So in the usage plan, you have to kind of refer to the API key. The reference kind of goes in that direction rather than from the API key to the usage plan. You might think, or intuitively, you might think it would go the other way, that the API key configuration would have a reference to a usage plan. In fact, it kind of actually works the other way. And also, the usage plan in its configuration, you refer to the web API stage that the usage plan relates to. That's how they are uh, interlinked with one another. Down here, then I'm showing, well, okay, we've got a web API and it has, let's say, two endpoints, and we want this endpoint to be secured in the sense that you can only access this endpoint if you have, essentially, if you include this API key in a request to the web API. Uh, and what, so given that I've created these connections here, then when a request comes in and it includes this API key, then the API gateway will allow the request, and let's supposing it's this endpoint is being targeted by the request. API gateway will allow the request to go through to the eventual Lambda, and the Lambda gets triggered. If the request obviously does not include the API key and it's trying to access this endpoint, then clearly it's going to fail. And if the API key value that's included in the request is not the same API key value that was generated, then that's not going to work either, obviously. So really the purpose of this diagram, of this picture, is to show you, how you kind of connect them all up together. Now, I'm purposefully not giving you the code for this because it's going to be one of the requirements in the assignment spec. So you're going to have to look up that stuff yourselves. But I'm hoping that by showing you these kind of relationships, it will help you to understand the whole kind of configuration that's required. And that's all I want to cover with API Gateway. There's lots of other aspects to it though, but we've got the essentials, I guess. Let me just check my time. Okay. So at this stage now, you have all you need to know in order to complete this week's lab. This week's lab being this one here. So I'd like you to work through that. Uh, I have this in a, yeah, I've got this now in a separate section from serverless, but um, it's kind of linked to what we've been working on over here so far, which is really all about kind of web APIs. But there's this other service called CloudFront. And what CloudFront allows us to do is to look at deploying full stack apps. Web API is going to be part of that, and we know how to deploy Web API on the AWS platform anyway. But how do we deploy your web client? And how do you kind of link your web client to your Web API all on the AWS platform? And part of the solution to that is to use this new service called AWS CloudFront. Okay, so I've only got slides in this section, but I've got some demos as well, which are going to be very important for you. So my slides are, exit this set of slides. Okay, so we need to do a tiny bit of background first, although it's more reminding you of stuff that you would have covered in the Web App Dev module. And we need to just refresh our understanding of what we mean by bundling a web app. Um, then we're going to look at uh, deployment of our front end or our web apps, deploying them to the AWS platform. What kind of services are available to us to facilitate that? And there are two in particular, S3 uh, and this CloudFront service. So then once we know how to deploy a front end, then we can look at the whole notion of full stack. So once we've completed this section here, then we now know how to deploy the front end to AWS. We know how to deploy the back end using the API gateway. Uh, the final piece of the jigsaw then is actually how do we kind of hook them up to one another so that we have a full stack deployment. Okay, so visually, this is how the deployment will all look. So we've been talking about all this stuff for the last couple of lectures, so that's fine. Over here, there is this other service called Cognito, which we won't get to look at, but what Cognito does for you is it takes care of all kind of user account management. It's a bit like Firebase. I know you've used Firebase, or some of you have used Firebase for user account management. Well, Cognito is the equivalent on the AWS platform. So that would clearly be part of the overall deployment of a full stack app. Over here, we have the S3 service, and that's actually where we deploy our front end, like our React apps, as we'll see. So this is kind of the background stuff that I just want to quickly go back over. So client-side web app bundling. And you might remember from the web app dev module, like there is the contrast between working in development mode and working in production mode. When you're doing your development of your web app, whether you're using React or any other framework, uh, typically you are using some sort of a special development server. Um, uh, you might remember using the Vite tool in the web app dev module. And the whole point of this development server is the development server is just a standard web server, but it has some extra instrumentation in it. And part of what the instrumentation does is it allows or it supports what's called hot module replacement. This idea that, you can, as you make changes to your code and you save the changes, provided your development server is running in the background, then it will push the changes out to your browser tab. So you kind of get an instant feedback of the effect of the code changes that you've been making. Okay, whether the term was used or not in the web dev module, that's what's called hot module replacement. That's what's happening in the background for you. Now, that's great when you're in development mode, but clearly you don't want that kind of feature in when your web app, when your client app is deployed into production, because hot module replacement obviously it's kind of slows down the whole rendering process. So there is this contrast between development mode and production mode. And also another way of kind of contrasting those two environments is we talk about a dynamic version of our web app versus a static version of it. The static version is what you use in production. The dynamic version is what is being used in development mode. And this is the kind of command sequence that you would have probably ran, I'd say, last year. So let's supposing I've developed a React app and it's inside in this folder here. So I'm CDing down to this folder. And, we would do npm run dev. Now, what that command is actually doing is it's starting this development server that I was talking about. This server that has all the special instrumentation to support hot module replacement. Excuse me. You start that up and you start playing with making changes to your code and seeing what the effect of the changes are in the browser, etc., etc. Eventually then though, well, let's skip over this for a second. Eventually then you've got to create a production version of your web app, and this is the command that you tend to use if you're using the Vite tool. So npm run build, that essentially takes your source code, all of your React source code, and creates a static version of your React app, and that's what you deploy then into production. But if you want to see what your static version of your React app looks like, what you need to do is you need to start up a local HTTP server, just a standard raw HTTP server. Now, there are tons of them out there. One of them is that you can access is a server called Serve, and you can install it as an npm installation. So that's all I'm doing here, npm install Serve. So that just downloads it and installs this Serve HTTP server. And then I'm starting the HTTP server and I'm pointing it at the static version of my React app. So this dist folder would have been created by this command here, and inside in the dist folder is our static version. To see all of that in action, I'm conscious of time now. Probably won't get any further than this now, but let's just do it anyway. So what I've got here is it's a React app. It's a fairly minimal React app, yeah, and you'll recognize maybe this kind of stuff. I think it's actually okay. It's written in TypeScript, but that doesn't really matter. It can be written in JavaScript. I don't think he did TypeScript in the web app dev module, but you're familiar with. Look, here's the use effects hook that you're familiar with, and the use state hook. So it's certainly React code. Use state. Yeah, so it's a React app. There aren't any components in it, I don't think, are there? No, there are one or two. There's one component. That's all right. So it's a React app. And I could do npm run dev from the command line here. I didn't do it beforehand, actually. I probably should have. npm run dev. And, you've done all this many, many, many times. So let's just go to wherever it's telling us to go to. That's my React app. Not that impressive. Okay, that's fine. And I could go making changes to my code. And once I save the changes, then they'll be reflected here straight away. So this is the kind of dynamic version of my React app. Now, eventually, I want to deploy it into production. And to do that, just stop my server. I go npm run build. And what that has done is it has created, in the case of the Vite tool anyway, it has created this folder up here called the dist folder. And inside there is the static version of my React app. Yeah, so there is a file inside in the assets folder. So it's, which one is it? It's this one here. Yeah, so believe it or not, that's all of the JavaScript of my React app packed into or bundled into one file. Remember that was the heading on my slide, client web app bundling. And all of the CSS would have been bundled into this single file. So this folder now contains a static version. Clearly, I cannot go editing this code. It's compressed and minified and all that kind of stuff. But to make sure that my static version is um, is rendering properly, then I can run that local HTTP server that I've installed, and it doesn't really matter which one it is, but I'm using the serve one. Starting my serve HTTP server, I'm pointing at, telling it where the static website. This is essentially, this folder essentially contains a website, where it is, and start it off. And it also uses localhost port 3000, just coincidentally. And if I go to that, then it looks the exact same, not surprisingly. So going back to AWS, so I now have a static version of my web app. Can I deploy that to AWS? Uh, and the answer is you can. And the simplest way to do it is to deploy it to the S3 service. So the S3 service, as well as it being a kind of file and object storage service, you can actually also use it as the host for a website. Uh, that means then that we could, or does that mean that we can use the CDK framework to deploy a website? And the answer is yes, in our case, where the website is our static version of our React app. And so this is the CDK code to do that. Pretty straightforward. So yet again, there's another L2 construct, this one here, uh, where we're creating an S3 bucket. Most of the properties are standard, but there's a key property down here, this one here. If that property is set in your configuration of your S3 bucket, then that's essentially telling the S3 service this bucket needs to be interpreted as a host for a website. If you leave out that property, then the S3 bucket is just a standard storage medium, kind of file stroke object storage medium. But by including this S3 will now actually, essentially what it will do is it will generate a URL for your S3 bucket, and it might look like something like this, and that will be a URL that you can put into your browser, and it will display the index.html that is contained within the bucket, and it will, you know, it will essentially use the bucket as the source for a website. So now this just creates the bucket though, and it configures it as a source for a website. What I'm doing down here then, and this is all part of my CDK stack, what I'm doing here is I'm uploading my website to that S3 bucket. Or maybe to use the, I'm doing a deployment. What's it doing? Bucket deployment. Well, okay. Uh, in plain language, what this code is doing is it's uploading all of the files that make up my website. And in my case, I'm pointing at the dist folder. So I'm saying take all the contents of the dist folder and any subfolders within it and upload those to this particular bucket. And it's as straightforward as that. That's how you can deploy a um, a website to uh, to AWS. Now, what the nature of that website, AWS doesn't care. In our case, the nature of the website is it's a static version of a React app, but a static version of a React app is just a website. And so a URL like this now would actually allow us to load our React app into our browser, which is where the React app is being hosted on S3. Okay, so that's fine, but it's not really that useful. You know, if your website or your React app is being accessed globally, then all of the requests are going to be hitting a single S3 bucket. And from a performance point of view, that is going to have an impact. So is there a better way of deploying a website stroke web app to AWS such that we get a reasonable kind of performance in terms of latency anyway? And the answer is yes. And the answer to that is to use a service called CloudFront. And CloudFront actually uses S3 as well behind the scenes. Uh, so due to time constraints now, I can't uh, start looking at this today. So we'll pick up the story on this next week. Okay, that's about it. But we don't need to know about CloudFront for this week's lab. So if you haven't started it already, you should start into the lab straight away. And I may well publish the specification for the first assignment before the end of the week as well, so that you can have a look at it and prepare any questions that you might have for me on it. Right, that's it. I will touch base with you tomorrow if any of you need to turn up to the lab. Thanks. Bye-bye.